So the pink sheet that you picked up when you came into the room today, that is extremely important for you. That is your go-to jam for the rest of the year. Okay? That's why it's on cardstock. That's why it's pink, because pink is my favorite color. And so you need to have that with you at all times. I shouldn't say at all times, but make sure that you know where it is. Put your name on it in case you lose it. Put it in your binder, your folder. Should be on top at all times because that's your trig identity. Okay? Now, we learned some of them in the Obviousities. Okay? We're going to learn the rest of them this year. Okay? So we're going to go through all, what is it, 27, 26, all 26 of them yet this year. Okay? So just so you know. Okay? 3 things I want to accomplish today in class. Thing number 1 is I want to go over the Obviousities packet. So if you have that Obviousities packet, you should get it out right now so you can follow along with me. Okay? Thing number 2 is I've got a 3-question exit ticket, if you will, for you to do just a quick little thing. Not going to be graded, just to make sure that you have those answered, so that you're understanding what we're talking about. And then at the very end, after you're done with that exit ticket, then I've got a trig values worksheet number 3 for you to do. And you'll pick that up when you get done with your exam. Okay? All told in the 80 minutes, I'm looking at maybe all told 60. So, and then you'll have to work it. Okay. Also, drawing your attention, it's at a couple of spots. Tuesday the 13th, we actually pushed that back a little bit. We had talked about doing it next week, Thursday, but we pushed that back to Tuesday the 13th. Okay, so the test, so new date for the test. But that week is also your unit circle extra credit project. So 2 things to do that second whole of December. All right. So obviously we're going to be talking about the Obviousities of the unit circle. So there's the unit circle. You might want to, if you've got a unit circle too, I know I'm having 3 things now. Your unit circle too, just so you see it. You can reference it. If you don't want to and you want to look around, you can see up on the window or up front here, or some of the other ones around the room. That's totally fine. But we'll need that too. Okay. So my plan is to go through the 6 pages of the Obviousities packet. I think there were 6, or were there 8? 2, 4, 6, 7, maybe? 2, 4, no, only 6. Okay, only 6. All right. So you should have, if you've completed your Obviousities packet, which should be done by now, you should have this box filled on the first page. That's kind of a reference of, the 6 different things that we talked about on the Obviousities. So I'm not going to spend much time with this, but I want to go through, that's great. But I want to go through this part. Okay? So the very first thing that we talked about in the unit circle was the fact that because it's a unit circle, and because we defined at the start that the cosine of an angle was the x value, and the sine of an angle was the y value on the unit circle. Points that are on the circle have that. That tells me then that the biggest my x value can be is 1, which means cosine can maximum be 1. The smallest that the x value can be is -1, which means the smallest the cosine value could be is -1. So all of the x values have to be in between 1 and -1. Same with y, all between -1 and +1. So then, since cosine is x, cosine has to be between -1 and +1. Sine, since sine is 1, sine has to be between -1 and +1. Okay? You cannot, and hopefully you know this by now from when you were in geometry, when you did some trig stuff last year in Algebra 2, you cannot have a cosine or a sine value bigger than 1, smaller than -1. It has to be in that range. So if I ever gave you if I ever gave you this, and I said find theta, you can't do it. It's not possible. Okay? Because this value right here, this value right there, has to be between -1 and positive. Okay? Not positive. Which we'll get into theta finding tomorrow. But that's where we're going to be using that too. Okay? Any questions on the bottom part of page 1? If memory served me right the first day of Obviousities, people pretty well understood that one and got through that one pretty quick. Okay? Page 2 then, at the top, we talked about the hammer. Okay? And so, since the equation of the unit circle was x squared plus y squared is 1, the circle centered at the origin, radius of 1, that means then that if we substitute cosine for x and sine for y, that means we get the hammer. Cosine squared plus sine squared equals 1. Okay? Now, this note in this box is important. It's all about where the squared term is. So these two right here mean the same thing, but they are different than those two. Because the box, you're squaring the angle. You're not squaring the trig part of it. Okay? So just be careful how you write it out. Okay? Either put it all in parentheses or just square the trig operation. Okay? Now, we can use the hammer to find trig values when we're doing it. Okay? And the reason that this plus or minus has to be in there is twofold. One, because we're square rooting. We square rooted here and there is where we square rooted to solve it, because we wanted to solve for sine. Okay? So that's one. We're solving and we're square rooting. That means a plus and a minus. Yes. The real reason, though, is because if I say that my cosine value was 1/2, there are two spots, pi over 3 and 5 pi over 3, where the cosine value is 1/2. So I haven't given a second condition. I'm trying to think, I was going to say classification, but I didn't give a second condition to narrow it down to just one. Later on in the packet, we'll narrow it down to one quadrant. But for right now, if there's no second condition given, that plus or minus is extremely. At the bottom, or actually it's in the middle, I should say. In the middle, if sine of t is 5/6, what was cosine of t? You should have solved that for plus or minus the square root of 11 over 6. Any questions on number 2? Okay. Number 3, then at the bottom of page 2, talks about what's positive in which quadrants and what's negative in which quadrants. So it says here that cosine is positive over here on the right half of the unit circle, quadrants 1 and 4. And that's true. Cosine is negative then on the left half. Sine is positive on the top half, negative on the bottom half. I'm going to add something to this too, and I'm going to say where is tangent positive? Yeah. Which quadrants would tangent be positive? And why is that? Why is tangent positive in quadrants 1 and 3? Who's placed? Okay, and a positive divided by a positive is positive, right? Okay, because tangent, remember, is sine over cosine. So if sine is positive in quadrant number 1 and cosine is positive in quadrant number 1, positive divided by positive is positive, so tangent is. Okay? If in quadrant 3, cosine is negative, so is sine, so negative divided by a negative. Which then means that tangent is negative in quadrants 2 and 4. Okay? Good times. Any questions on the positivity of those things? Okay. Now let's get into some of the more meat of what's going on here with the obviousities. Okay? If we have a wrap value, okay, and remember we called the wrap value the distance that it took to go that angle, okay, which was the radian measure of it, because we learned way back when we were starting that the radian, or the radius of a circle, or a radian is equal to the length of one radius on the unit circle, or on a circle along the circumference. So if I add 2 pi to that, where have I gone? If I got a wrap value of t, and I say, and now I add 2 pi, go all the way around, and where do I end up again? Same spot. Okay? So that's if I add 2 pi, right? That's 1 revolution. 4 pi would be 2 revolutions. 6 pi, 3 times around, always ending up still back in that same spot. So when I add 2 pi, I'm going that way around. Or 4 pi, or 6 pi, or any even amount of pi, right? It's got to be an even amount of pi to go all the way around. So if I added 122 pi, I would end up in the exact same spot. Now, the kicker is we can subtract 2 pi, and then I would be going this way around the circle. But again, the same logic holds. Meaning, if I subtract 2 pi from my angle, I'm going to end up in the exact same spot. Now, why is this important? Well, the real reason that this is important is because not every angle, I think there's some on here, there we go, not every angle fits on the unit circle. Sometimes they're too big. 13 pi over 6 is too big. It's not on my unit circle. If I'm going around 13 pi over 6, there's 1, there's 5, there's 7, there's 11, which means this is 12. Not on my unit circle. So I need to get it back down to my unit circle. So the reason that this one is important is because we can take here that 13 pi over 6 and we can subtract 2 pi, which is like 13 pi over 6 minus 12 pi over 6. And so then that just is the same angle as pi over 6. And now I'm on my unit circle. I can find the sine. I can find the cosine. I can find the tangent. I can find the secant, the cotangent, all that. Okay. It also works for negative angles because historically, and I get it, I 100% get it. It took me the longest time to figure it out too. It takes a while to figure out negative angles because they're not written on my unit circle nice and pretty like that. Very few people have the wherewithal to say, oh, this is, I should write it on my unit circle. This is negative pi over 6. This is negative pi over 4. This is negative pi over 3. This is negative pi over 2. This is negative 2 pi over 3. This is negative 3 pi over 4. This is negative 5 pi over 7, or 5 pi over 6, so on and so forth. Okay? And that's fine, because you don't have to. What this is saying is, if you got down here, negative 11 pi over 6, then, oops, I guess I got it written right there. I don't even need to redo it. You got negative 11 pi over 6. You can add 2 pi. This is like adding 2 pi here, but really I'm adding 12 pi over 6. And now, negative 11 pi over 6 plus 12 pi over 6 gives me pi over 6. And now I can find the sine value by saying, yeah, that's at pi over 6. Extremely important. Here are the answers to those bottom ones that you were supposed to do if you wanted to check them. Good on this? Yeah. Okay. Then we went to idea number 5. So now, instead of going all the way around the circle, now we're only going halfway around the circle. So now I'm adding or I'm subtracting pi. Okay. So what we found, or what you should have found in this one, is that if we go halfway around the circle, everything is opposite. Okay? Sine is opposite, cosine is opposite. The only thing that's not opposite is what? Tangent. Tangent and cotangent. The only two that aren't opposite. Because if the other two are opposite, it comes right back to it. Okay? So if I'm at pi over 3, and I go halfway around the circle, if I add pi or subtract pi, I'm going to be down here at 4 pi over 3. And my x values are opposite, my y values are opposite. So sine and cosine halfway around the circle are both opposites. Okay. And this is where letter E comes in, which actually shows up then on your trig identity sheet. Maybe not. Plus, minus pi, plus 2 pi, half pi. Nope. Oh, there they are. 8 and 9. Showed up on 8 and 9. Tangent we said was equal then, so that's why it didn't. That's why we didn't put it on there as 1, because tangent halfway around the circle is the same. Any questions on, what was that, 4? No, 5. That was 5. Okay. 6 now. The tricky one is negative angles, negative t values, going in the opposite direction, negative wrap values. Okay? So if we start and we go to a certain angle and we go in the positive direction, the counterclockwise direction, we're following the black path on the board. We get to a spot. But then I say, ruh-roh, should have went the other way. So go back to the start, and now we go follow the red path. Okay? If we do that, so for instance, if this will come through a video because I don't have the window posted. Okay? So if I start here, and I go to 5 pi over 6. Right? Okay? So I went that way. Now if I go 5 pi over 6 in the negative direction, it should have brought blue. Before you sit down, let's go grab the blue up. Okay? So here now, I got 1 pi over 6, 2 pi's over 6, 3 pi's over 6, 4 pi's over 6, 5 pi's over 6. So down here is negative 5 pi over 6. I can do this today because okay? Notice, so now I'm looking here at this x value, y value, and this x value, that y value. What do we notice about the x values? They're the same. What do we notice about the y values? They're opposite. Okay, right? And that would work no matter where we go on the unit circle. Okay? If I went to 2 pi over 3, okay, I would be here now. And then I would go to negative 2 pi over 3, I would be here. Yeah. But again, x values are the same, y values are opposite. Usually the first time you write up the window in class, they're like, it's dry erase. What's up? Get it in a minute. Okay. So we got that. Okay. And then, but, so the difference there is tangent. I should go back up here first. Okay. So cosine is the same. So cosine of negative t is the same as cosine of t. That's number 1 on your identities sheet. Okay? Sine is opposite. So sine of negative t would be negative sine of t. That's number 2 on your sheet. Okay? But because since sine is opposite and cosine is the same, now tangent becomes opposite. So the tangent of negative t is equal to negative tangent of t, which is number 3. And then those would also be 4, 5, and 6. Those would also follow the same pattern for secant would follow cosine, cosecant would follow sine, cotangent would follow t. Okay. How we can use this is we can say here, for instance, on cosine of negative pi over 6, so cosine of negative t is equal to cosine of t, so we can just write that as cosine of pi over 6, and then we go. We could also have added here, it's a little bit faster to do than saying negative pi over 6 plus 12 pi over 6, what we were doing back when we were doing full laps, gets me 11 pi over 6, and that's really what I'm going off of on that one. Okay? You can still do that, but when you've got negative wrap values, you can also just use those first 6 items. Okay? Questions on those? Is it? I would just flip it, because the chances of you screwing up adding or subtracting are lessened. Okay? And you'll be able to use this identity sheet on most of your tests. I think from now on we let you use them pretty much. You might not use this exact one because you can write notes. Like this would be a good time, like now, to start writing a sheet to start writing notes and key formulas and stuff on that aren't on there. We have for tests and quizzes. Oh, that one's got to be a circle on it. I don't want that one. We have right here in front of me. We have a classroom set of them that we would hand out on those things. So either. But if it's like if this were negative 13 pi over 6, then I would for sure do it, because then it's it's still off unit circle in the wrong direction. Okay. Then we had on the back side, we talked about using the hammer and all of these fun things. And then we talked about which quadrants they were in. Apparently not. That must be on roll cut bricks. There we go. So we've got those. Questions on any and all of that? Okay. So what I would like you to do now, and we can always go back to this, I also have copies of it up here too. We have an exit ticket somewhere on a scrap piece of paper. I don't care what you use, or if you start anew, if you want to even do it at the bottom of the Obviousities packet, that's fine. But do these three, then bring them up to me, get them checked, and then I'll give you worksheet number 3. Those of you that came with conflict, this pink sheet that you picked up when you walked in, that's very important. Keep it with you, keep it handy. It's your identity sheet. We're going to use that for the remainder of the year. If for some reason you lose your identity sheet, you do have extras. You always need extras. It's not going to help because I got to do it here. So number 29 today.
first one. Ignore the sweet. Yep, don't like that one. Don't like that one. And don't like that one.
I offered.
What a sweetheart you are. Okay, that wasn't the one. Let's see if this works. Did it go away? Oh, perfect. Let's see if this works. I gotta restart my computer.